So now in this video, we're going to make a Schmitt trigger with an op amp. The circuit that we'll be making a Schmitt trigger out of is the non-inverting comparator. So really what it does is you take some of the output and feed it back to the non-inverting input, which helps hold the output to a degree. So you have a little wiggle room hysteresis where it's going to kind of stick where it is, and instead of changing right at the reference voltage that we set. So we already looked at the non-inverting comparator a couple videos ago, and so we're going to rush through that really quick. So I already have the 10 kilo ohm trim pot on the board right there, and you can see it's connected to the third pin down. And the reason why, we'll grab this kit that I got my LM358 out of. You need to power them. You'll see those power pins in those two spots, and the outputs on the top, inverting inputs below it, non-inverting below it. There's also an op amp over there we can use if we want to. We're not going to. And it looks like it doesn't make much, if any, difference if we leave these pins floating, those inputs. Some integrated circuits, it's really not good to do so. So now, that is our variable voltage, and then we're going to make a voltage divider. Equal value resistors, one to the positive rail, one to the negative rail. That's going to go to the inverting input, which we saw before is the second pin down. So I wrote 100,000 ohms resistors for that on the schematic. I'm going to use 10 kilo ohms. Doesn't matter. Lines are equal value. You will get half of the supply voltage. So that one goes to the positive rail. This one goes to the negative rail. And I can see the color on there on camera pretty decently. Red stripe there, red stripe there, that's the multiplier. So it's easy to grab the wrong resistor sometimes if you're not paying attention. So I set those to the output. Wrong spot. There we go. Just shoveling it down one row. There we go. Now we have it. So we're going to add our load first. The Schmitt trigger part is this resistor right there. But before we do that, we're going to add the LEDs. Just take a quick look again at a non-inverting comparator. So allowing to lead the anode to the positive jumper up there. So even though the resistors to the positive terminal are 5 volt supply, in this case, we can put the LED before the resistor. Doesn't matter, they're in series, the same amount of current goes through them, it just matters the direction of the LED. Allowing to lead the anode needs to be more positive. Same thing with this one. This one's going to go to the negative rail here. And the LED has less reach unless you stretch out these pins. So short lead, the cathode, is going to that gray jumper. And we will add the protective resistors. We're dealing with 5 volts. Actually, it's less than that if you want to get technical, because we're losing some voltage due to the op amp output not going all the way to the rails. But it's close enough to 5 volts. 220 ohms will work just fine. So there we go. Now the power supply is off. This is a comparator circuit. We set half of the supply voltage, output is on, and our reference voltage is halfway, so if the trim pot's halfway, looks like, so that's the positive rail, so the output's low now. If I turn it up, there you can see that the output changed, and it should not be changing up here. I don't know what I did wrong. That doesn't look good. It should be halfway. Oh, I have both these resistors at positive rail. So I'm going to leave that. That's easy to do. There we go. Now halfway. The output is not going low for this one. There we go. The resistor is just loose. So I'm going to leave those bloopers just because it's already a short video. It's a quick video series, and they pop up from time to time. So don't feel bad if it happens to you. I make more mistakes while I'm making a video though. Now, I actually want to, this will work. We're a little cluttered here. I'd like to move that resistor, make a little more space, but this will work. I'm going to grab the 4,700 ohm resistor right here. That's going to go to the output and then to the non-inverting input, the plus input, which is 3 pins down. So again, it's kind of crowded, but I'm going to the top pin and then third pin down, and didn't really want to slide in. So we kind of have a risk of shorting things, but they're resistors, so they have resistance. But in any case, there you go. Now, even though the wires are close, they're not touching. And we saw before we had the halfway point before it would change, so now the output's high because the trim pot's high. But you can see I got to go back over this much ground. So that's why I used a 4,700 ohm resistor. Higher value resistor, we'd have less wiggle room here. Lower value resistor, there'd be more wiggle room. In fact, if you get low enough, all of a sudden it'll hold its position even if you go all the way to the rails. But there you can see, right now we have to go to about that corner before the output will change. Output's low right now because this is closer to low, and then the output's high right now because this is closer to high. It's a non-inverting input. So this middle area is hysteresis. It's the area where the output's going to stay the same as you last put it in until you overcome and switch. Now again, we're in that middle area. I did go up enough to flip it, but we're in that middle area. It's holding until we flip it. We got that middle area. That's why I use a Schmitt trigger. When you want it to change once it reaches one extreme or another, but you don't want that change to be one exact spot. You got that positive feedback where the output is holding the voltage closer to what it is, the voltage that the output is trying to be more like. It is holding it more like what it already is until you overcome that difference. And then when it flips, then it holds it again more like what it already is. So hope that all makes sense, and I'm going to end the video there. Thanks for watching. Check out one of the other videos I'm posting. Look at my Patreon site too. I could really use some more Patreon support. So do that. I'll see you in the next video.